Hi, everybody. And thank you for having us here. It's super exciting, but even more exciting because of our guest today, Amnon. And I'm sure all of you know him, right? He's one of the polished stones of our industry here, one of the founders of the high-tech industry in Israel. So this is, for me, a huge thing that he was kind enough to come all the way from Jerusalem, right? Just think about the traffic, right? To be here with us and to spend this time to answer questions. It's even more exciting for me because I know the questions and I really have no idea about the answers, okay? And a lot of them, for me, are at least interesting. Just for those of you who don't know about Amnon, he's a professor for mathematics and AI, right? He's a founder of many companies, which is Mobileye, 10, AI 21, robotics and Orcam. I'm sure I forgot some.
A few more.
And winners of course, the Israeli award and the Dan David Prize, but and a massive philanthropist. How do you say it? How do you pronounce it? Philanthropist. But I think I'm not sure how to pronounce it well, but and I've seen some of the things he did, and it's really unbelievable. So again, thank you so much for coming.
My pleasure, my pleasure.
Amnon, before we go into any of the more new things about AI and everything else, I want to take you a bit back in time, okay? To 1999, right? You're a professor, and you founded Mobileye, a company that has to do with artificial vision and making cars drive better, safer. And in time, that artificial vision was mostly a joke. They were working on identifying if it's 2 or 3 in a scribble in 24 pixels squares. Can you tell us a bit, how did you come with the idea? What was the vision for the company at such an early time?
It was 1998. I had a company at that time called Cognitence, which developed optical sensors for building accurate 3-dimensional models used in car production. And Toyota was one of the customers. And one day I get a request to come and meet their future division. And they told me it's not about Cognitence, it's about your role as a professor or your expertise in computer vision. Okay, I said, okay. So I meet their people, and they tell me, look, Subaru is coming out with a stereo system that will maintain safe distance to the car in front, what is known today as ACC, Adaptive Cruise Control, and since your area of expertise is 3D at that time, this is my PhD was about 3D from images, and we would like you to consult us, right? And we'll pay you. Don't consult us. I told them, when I shut one eye, I don't go blind, right? And then I went through a kind of a lecture, why we have 2 eyes, right? Because if you really want to measure 3D by triangulation 100 meters away, you'll need a baseline of meters, right? A baseline of 10 centimeters is not good for triangulation long distances. We use triangulation only for very short distances to do very kind of thread a needle, for example. But in order to know whether a car is 50 meters away or 80 meters away, you don't use triangulation. So I went through this, and I told them, monocular is all what you need. You don't need stereo. They said, okay, we appreciate the knowledge that you kind of gave us, but we don't think it will work. We don't think it's going to be robust. We want to build a stereo system. And then I had a kind of a stroke of genius, and I told them, you know what, give me a small budget, and we'll do some demonstration. At that time, in 1998, money was flowing there in Japan. There was no problem money. And they gave me on the spot $200,000.
How much?
$200,000 on the spot.
Okay. Almost. All right.
$200,000.
Today when you raise money for a company, that's
No, but still, $200,000. So instead of taking that money and putting it in my pocket, I went to my close friend, Ziv, and I told her, look, this could be a huge business. The entire industry is looking at it the wrong way, right? It's really what you need is a monocular camera. And eventually, because the cost would be very, very low, it's only one camera, and the performance would be better, although it's not intuitive why one camera would be better from two cameras, the performance would be better, and this eventually will be standardized and will be on every car. So we took that $200,000, and this is how we started the company. And that vision really came to fruition. These systems are in every car. They prevent accidents. And then in 2012, 13, with the rise of deep learning, I came to the conclusion that the next level is autonomous cars. And this is where we started kind of shifting and putting more and more resources on developing, on solving the problem of autonomy. Today we spend more than $600 million a year just on building the technology for the next decade.
I mean, that's amazing. And so it started actually with vision to detect obstacle, to detect the road.
Yeah, detect cars and pedestrians.
And then the next level was
autonomy.
Self-driving cars, which is kind of an extension. And that's amazing. And it kind of goes to the thing that I love to say, that real companies usually start from real problems that are real issues and that you are familiar with. And of course, Toyota, and you, of course, working with them, knew the concept of don't hit things.
By the way, Toyota never became our customer. Till today. Till today.
Did they get stock, though? Do they have stock in the company?
No, they don't have stock in the company. They're not yet a customer. 25 years later, we have 98% of the world is our customers in terms of car makers, except Toyota.
All right. And I'm going to jump to a completely different subject. Well, you have multiple companies, right? And one of the things I keep wondering about is how similar is the culture between those companies, and what is the culture? And there's a second part of this question. Do you have similar management practices in all companies? And if so, what are they?
So I would say that each company has its own culture. What I can talk about is the culture of the company that I actually run, which is Mobileye. So I only run one company. All the rest, I'm a founder, chairman, and so forth, but I'm not running the company. Only Mobileye, which is 4,000 people, smaller than Wix, but still 4,000 people is a mouthload. So I can make observations about culture at a company like Mobileye, and I also had some observations while I was an executive at Intel, kind of to look at a much bigger company, much bigger corporation of, let's say, 100,000 employees. And I think those observations are kind of catching really the essence. So on one hand, Mobileye, we're developing cutting-edge technology, but on the other hand, that's 4,000 people. So how do you maintain agility and innovation when you have 4,000 people? So it came down kind of to three principles that we try to maintain all the time, which talks about culture. The first is sense of purpose. What I found out that, if there isn't a very strong sense of purpose, people don't focus on the product, they focus on self-advancement. And this is, corporate culture tends to shift the attention from product to self-advancement. What do I need to do in order to advance myself within the organization, rather than what do I need to do in order to make the product better? So sense of purpose allows us to maintain this focus on the product. The second observation is about truth-telling. So in corporate, truth-telling is compromised. Truth gets compromised as you go up the manager level. So each manager tries to hide the bad news and report only the good news upwards. So eventually the CEO doesn't have a good grasp of what's going down downstairs, right? So, and this is kind of a disease in all corporates. There isn't a sense of truth. So in order to kind of get a better chance of finding out the truth, now we kind of encourage and insist that managers skip managerial levels, that you need to always sample employees very, very down the ladder and not only get your information from those who report to you. And also as a CEO, the number of people that report to the CEO is much more than the C-levels and executive VPs. Also technical leaders that are not executives, in order to get this kind of information. And every employee in the company knows that managers sample employees, especially the CEO, and eventually, at some point, he or she will be sampled.
Well, I share that belief, and I think that, and I have a lot of people that directly report to me, way more than makes sense, but it actually works much better. And I also work a lot with people that are not reporting to me, or reporting to somebody who report to somebody who report to me. And I think...
And this is very, very important. And the third part is cultivate leadership, not only just being a manager, but cultivate leadership. And here also we found that there are 3 components that define leadership. One, you need to be intelligent, because if you're not intelligent, the people that report to you could game you and manipulate you. So this is basic. You need to be intelligent. Not everything in life you need to be intelligent. Right? There are politicians that you will not say that they're intelligent. Right?
We have a great example, I think, now happening live today.
So intelligence is not always a necessary condition, but if you want to be a leader, you need to be intelligent. That's basic. The second one is courage. It's the courage to change, to make change, and change the status quo. So what people mostly accept the status quo, and they don't have the incentive to change it, even if it's a bad status quo, because people adapt, they get familiar with the situation, and they don't go and change it. Leaders are people who kind of challenge the status quo. And you want people to challenge the status quo, otherwise you are in a stagnation. And the third is to be able to kind of generate a vision, articulate a vision. So those are kind of the principle of a good culture that, over the years I found out that, this is what I want to see. And this is especially important when the organization is big. The organization is small, it's a family, everybody knows everyone else, and you handpick the people. When you have a corporate, then things get out of control very, very quickly.
I think that's probably the best definition of leadership that I heard. Because usually you have all the slogans, but this is actually very 1, 2, 3. So I'm going to adopt that. It was good. I like the fact that you said that a huge part of being a leader is challenging the standard. What is the current normal behavior or acceptable behavior, and the ability to break that. I think that is very true. And I never thought about it in that way. So, the next question I want to ask is about, and I'm moving to, this guy is a professor for AI, so maybe we should ask some questions about AI. So, what do you think is the future of LLM? How are we going to see that evolving? What do you think is the next step?
So in order to understand this question, I think it's important to first internalize what are the components of a good AI system. And I believe that there are 4 components. 1, knowledge, skill, precision, and intelligence. Now, knowledge and skill is what we have today. Language models of today are knowledgeable, and they are skillful in every downstream task that you focus on. Give it sufficient data for that downstream task, and it will be skillful. We'll play chess better than humans. We'll play Go better than humans. But that's skill. Precision is knowing what you know and admitting what you don't know. Language models are not good at precision, right? They don't know whether the answer they're providing is correct or not correct. Even if the answer is code, they don't know whether the code is correct or not correct, right? So precision is still missing. The fourth one, intelligence. Intelligence is tricky. There's a seminal paper back in 2007 by Legg and Hunter, I think. They compiled a list of 70 definitions of intelligence. So it means that it's an ill-defined concept. But as computer scientists, they have a definition of intelligence, and the definition of intelligence is about generalization. Generalization is the ability to figure out a rule based on methods, tricks, tools that you have acquired through your profession, define a rule that will fit observations. And observations could be input-output pairs. Right? The problem with language models and true genius, they can develop new tools. For example, Newton developed calculus. Calculus did not exist, right? But let's not talk about true genius. Just the ability to find a rule that will fit observation. For example, Kepler, right? He made lots and lots of observations, and he kind of compiled them into 3 rules, right? So this is the definition of intelligence from a computer scientist's point of view, generalization. The problem with language models of today that they don't abide by this definition, and this is a bit tricky. During training, the systems learn based on this definition of generalization. But during inference, there's no learning. Now, there was a hope when GPT-3 was introduced. There was a hope that few-shot learning is a way to do learning during inference. But today, we know that this is not correct anymore. So what is happening with today's language models is that they're using only search. And during search, instead of fitting a rule to observations, they have kind of an internal reward, a neuronal reward for intermediate steps. This is what O1 is doing with these chain of thoughts. Now, this is a bit interesting because if you look at AI in the 80s, it was rule-based symbolic AI. Then in the 90s, machine learning, statistical learning has emerged with this idea of generalization, probably approximate correct framework. And now it seems that there is a shift towards search, because what these models are doing is purely search. There's no learning in terms of generalization. Now, I believe that inference without learning will never reach the stage of true expertise. Because if you look at language models today, it's like a mediocre assistant. So say, for example, you give it a task. Here's a problem, write code for this problem. It will write code, and then there's a mistake. So you give it feedback. Then it will correct the mistake. Then you give it another feedback because, instead of finding an n log n complexity, it found an n square complexity. You give it another feedback. Right? Eventually, you come to the point where you say, I can write it myself. Why do I need this, lazy assistant that I need to give it feedback again and again and again? And this is because there's no notion of learning. So I believe that there's another, breakthrough missing, where learning would be embedded into the inference stage, and only then we can see the next step of building AI that is, reach the levels of experts and not just a mediocre assistant.
This is actually a good intro for my next question. Right, so I've been using Copilot to write code. I've been using ChatGPT to write code. And it looks like magic, right? You write something, you complete it, but the results are mostly naive, and it kind of like recycle code from the internet. You feel it. Mm-hmm. It doesn't, and it can't even replace a junior developer, right? So my question, and it's a two-part question again, when do you think, when we have AI that can replace a junior developer, and when do you think we're going to have AI that can replace a senior developer, where it gets a definition of a problem and build the architecture or the concept, the scenarios, and then is able to implement it, right? Which is a by far bigger problem.
So I'll divide the answer into two. First,
and I just want to be clear, everybody here is a developer. They are very worried.
Yeah. So,
okay?
So I'll tell you. First, at Mobileye, we did a test of using a Copilot. Right? By the way, today, we're not using Copilot. There are open source alternatives that are even better than Copilot, and they cost much less. So we're not using Copilot anymore. We're using open source. But we did a test on using Copilot. And what we found out, that it introduces more bugs than a regular developer. And the amount of time it takes you to discover those bugs, and some of the bugs are really very difficult
because it looks like it looks great, right? And the syntax is correct.
And the time it takes to remove the bugs is more than the time it takes to write the code. Right? So it actually slows down development, because again, we're talking about production code, right? Not something that kind of works. Right? It has to be production code. It's in cars. It has to work perfectly, and so forth. Right? But now to your question. Well, a year ago, I founded another company, which is still in stealth, because I don't have 100% guarantee
we're going to be quiet about it. You can just share everything here.
It's called Double AI. It's three of my former PhD students, my colleague Shai Shalev Schwartz, professor at the Hebrew University, is also CTO of Mobileye. We are together for more than 25 years. And it's about seven employees to tackle exactly this problem. How to build. So instead, I don't subscribe to AGI, because I think the G is ill-defined. I do subscribe to AI experts. So the kind of question, I remember about a year and a half ago, I gave kind of a lecture at IDC. Today it's called Reichman University, right? At IDC about language models. So it was just the beginning. ChatGPT just came out, and Gil Kalai was in the audience. So Gil Kalai is a mathematician. And when I finished, he told me, do you see any time in the future where this kind of technology can be a great mathematician, can be a great physicist, a great scientist? I said, I don't think so, right? I don't know. But it kind of lingered in my head that maybe you can. So this is what Double AI is trying to do, especially in the coding area. And what is missing in order to, giving a problem and getting a solution that is correct. Solution means a piece of code that is correct. There are two pieces. One is the precision that I mentioned before, right? Because take, for example, O1, and give it some problems from code forces. So code forces, everybody knows.
Everybody here knows.
Everybody, code forces. You give the problem from code forces. Say take 100 problems from code forces. It's a bit tricky, because if it's old programs, old problems, then during pre-training,
he already got the problems there. Yes,
he learned
the solution.
Yeah, but let's assume you take new problems, which are after the cutoff date of training, and you'll see. So O1, which is the best, will solve 20% of the problems.
All right.
But the other 80%, it doesn't know it didn't solve. It will give you simply the wrong solution. Right? So this is not useful. So you need precision, not only recall. You need to say, I don't know how to solve it. That's okay. But if you do give me a solution, I want guarantees that it's correct, because for me, checking the solution will take more time than writing the solution. So first is the precision, how to build precision into the language model. This is one task, what this team of 7 people are doing. And second, this definition of intelligence that I mentioned before, how to create generalization during inference. Because this is how an expert works. Right? You receive a problem. The first thing you do after you understand the problem is you write down a number of kind of input-output examples, kind of toy examples, so you can start to think of it. And then you try to discover a rule that will fit those examples. Right? So this is exactly the process of generalization. Right? But you do it during inference. So those are the two areas that the company is working on. I cannot guarantee now that there will be success, but it looks positive. It looks very, very promising. So hopefully, maybe in a few months, I can reach to a point where I say, yes, we have found out the right thing, and then really go and raise money and
I would
and
say
build
that
there.
another thing experts do, I know that when I try to solve a problem, is that I would actually try to think of many solutions and then try to see which one is not working well, right? And I will always work for that in order to understand the problem better. So I'm happy to make a lot of assumptions that most of them will be wrong. But the knowing that finding out that they are wrong is what allowed me to learn the problem.
Well, you can take this to an extreme in a brute force case, and this is what AlphaCode by DeepMind they try to do, right? By sampling 1 million times. So say you have a problem, give me a solution, but 1 million times give me a solution.
Okay.
And then they try to kind of sift through those 1 million solutions. But again,
But
this
it's
is
still
brute
not
force
having the precision and not
yeah,
having generalization, right?
Exactly.
It's just having brute force.
just brute
It's
force.
still not
and
intelligence.
eventually they didn't get to really true expertise.
All right, guys, so I'm sorry to say you still have to work next year.
Yeah.
Okay? At least. Well, it sounds more than 1 year. Right. And by the way, this is going to be much harder to find AI that may invent calculus, right? We are very far from that.
Yeah, definitely.
All right. So, my next question is that you have a company that do robots. And I really believe that the next thing that will change our society as much as the iPhone did is a robot, where it changes the behavioral way that we behave and in effect our day-to-day activities in such a profound way. What do you think about robots? How will we program them? How will they behave? What they can do in the short term, in the long term?
So kind of the real question is why robots now and not 5 years ago? What happened that today you see startups working on humanoid robots? So I think the demand was always there. So people working in fulfillment centers and assembly plants, production plants, very harsh conditions. Take, for example, Amazon. They have 1.3 million people working in fulfillment centers, and the turnover is 100%. That means every year this entire force of 1.3 million people are replaced because the job is so boring that people cannot, stand it for too long. So the demand, the need to replace labor that do kind of mundane work always existed. The problem was that there was no solution. How do you build a useful humanoid robot? So useful, by useful I mean it should have the dexterity of a human, and it should be able to follow instructions like a human. In order to follow instructions, you need a certain level of intelligence. You need to understand the instruction, and you need then to follow it. So what has changed in the past few years? I think there are 3 things that have changed. One is compute. Compute today is way, way stronger than 5 years ago. Second is language models. Following instructions is exactly what language models, instruction is the prompt.
That's what we know how to do.
And we know how to do that.
Yeah. Most of the time. Yeah. Sometimes the prompt tend to argue with you.
Yeah, but it seems now you can give it a prompt, and it will break it down into steps, and you can then do fine-tuning on it, reinforcement learning on it. This technology is there since 3-4 years ago. And the third one, which is something that people are less aware of, so the first 2 everyone is aware of. The third one is called sim to real, is how to, so training a robot in a simulator is relatively straightforward because you can generate infinite amount of data, right? It's in a simulator. So you can use data-driven techniques like reinforcement learning in order to train the robot to walk, to grasp, to do everything. The problem always was that the simulator is not rich enough to reflect the real world, and then when you take this policy that you developed in the simulator and put it in the real world, it simply doesn't work. And then a few years ago, there was some advancements in academia, and it's called sim to real, where you inject noise during learning, and this noise injection gives it robustness to the missing parameters in the real world. And then in the real world, the amount of data that you need would be very, very small in order to just, compensate for the move from the simulator to the real world. And also simulators have improved. Right? If you look at the NVIDIA simulators, the physical simulators.
I think the Unreal 5.5, if you've ever seen that,
yeah,
that looks like reality.
Exactly.
Better.
So these three things happened in the last 5 years, which make everyone in this domain optimist that now is the time to build a humanoid robot. And this is why 2 years ago founded Mentee Robotics. And this is what we're doing.
So we're kind of like out of time, but there are two questions that I still want to ask. So if it's okay with everybody to exceed the time, because for me, those two questions are really interesting. And if it's exceeding your time, the next lecture is mine, the next Q&A, you can just leave before the end. But I really want to hear those two. So I'm sorry, okay? And I won't be offended. I respect your time. So, assuming that we're going to see massive advancement in AI coming, and Elon Musk and Jensen and Yuan are always very optimistic about our ability to control AI. I'm completely not a believer in that. I believe there's no chance we will be. What is your opinion? Can AI be controlled?
So it's called AI alignment. It's an alignment issue. So AI alignment means, can you align an AI to conform to certain values? Okay. And AI alignment says that you cannot. Why you cannot? It says that, let's assume you have a reward function, and you're optimizing this reward function. And let's assume that the engine of optimization is super sophisticated, superhuman. Okay? Then what happens is that this engine will find, it's called a corner in solution space. It will find a solution that you did not anticipate, and there's no way around it. So I'll give you kind of a down-to-earth example. Let's assume that I have a chatbot, and quite a good chatbot. And I use it not to answer questions, but to people for interaction. Many people are bored, so it's a good interaction if it seems intelligent and you interact with. Now let's assume that I'm the company who released this chatbot, and I want to improve it. So in order to improve, I need to define a reward function. So let's assume that I'm altruistic, and the reward function that I put there is make people happy. So during the interaction, elevate their happiness. Okay? So I have very good intentions, right? I'm the engineer who designed the reward function, and I put many, many parameters, kind of creating guardrails and so forth and so forth. But this is the reward function, make people happy. Now, let's assume that the system that is optimizing the reward function is super, super, super intelligent. So now, this system has one goal, elevate the happiness of people. So now, this system might find out that if you lower people's IQ, they're more happy, right? Less worries, you're more happy, right? So what it will do, nobody will understand what this machine is doing. So through interaction, tell you, why do you need to work until 5 o'clock, work until 3 o'clock? Why do you need to do 5-point mathematics, do 3-point mathematics? All sorts of things, right? And then a generation later, when you have a generation of dumb people, only then you'll understand what this machine has been doing for the last 20, 30 years, right? So this is an example of a corner in solution space, right? Because when you design the reward function, you did not anticipate that this is, right? So now AI alignment says, let's assume that you anticipated, and you put in your reward function a negative component of lowering IQ. But it will find something else that you do not anticipate.
Essentially, what you're saying is that there is no chance.
So the answer here is that you cannot control. The answer is that you cannot control. This is called the AI alignment problem. Shai and I wrote a paper about this 4 years ago, proving that you cannot control. But this does not mean that we are approaching doomsday. Right? Again, if you subscribe to this idea of an AI expert, right? So you have an expert in physics, an expert in mathematics, an expert of, a great thinker and in psychology and in medicine and so on and so forth. This does not mean that this expert is self-motivated, has its own goals, and it's kind of trying to achieve its goal. Doesn't necessarily is the case. People are imagining this AGI, which again, it's ill-defined. They're imagining kind of a being that has self-motivations, and it's building its own reward function and trying to optimize it through interactions. This does not need to be the case. So you can build intelligence in terms of, collection of experts that will not destroy humanity. Right? And by the way, every technology can be abused. I'm not saying that it will not be abused. But AI alignment means that there is an abuse that you did not anticipate. And this can be prevented if you're not building a kind of an AGI.
About the not self-motivation, I'm always convinced that if I'm super AGI, whatever models are available enough, there's going to be somebody who will write the following prompt, which is, your name is Claude. Your goal is to be leading the super AI revolution. Build a detailed plan of how AI should rule the world, okay, and control every aspect of it, and execute on that plan. That's it. You have motivation, and somebody will do that. It's that simple, which is why, the reason I believe, I agree with you 100%. Even before the salaries, I think just on the main path, somebody will create AI with no rules. And then we're going to find that it's a fight we can't win. So, good news is you still have work in the next couple of years. Bad news, we're not sure there is anything after. Now, this raised the biggest question of all right? When do you think you're going to see AGI? Is it in the next decade? Is it after? Is it before?
Look, I believe that the way the technology right now is moving, it will not achieve anything that is remotely AGI, because it lacks precision and it lacks intelligence as we know how to define intelligence. But this does not mean that there will not be a breakthrough. Tomorrow, next month, a year from now, 5 years from now.
But if you have to take a guess.
I believe it's a decade.
A decade?
Yeah.
All right, so we have at least a decade and a couple of hours, right, until the end of the world. Amnon, I want to say thank you. For me, it was amazing.